Hello, hello, hello. All right. That's it. You're done. Yeah, it was easy. Yeah. Is this on or is this not on? Is this on now? Testing, 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 testing. There it goes. Do they come and close the door? Does anybody know? Got it. Cool. All right, I guess we're right at it. So I guess we can probably kick this off. Can everybody hear me okay? Everything good? All right. Well, my name is Derek Morgan. I am with Spacelift. We are an infrastructure as code management company. And it looks like that HDMI might be a little finicky. Just let me know if that disappears and I'll make sure we keep that going. Probably going to let you guys get to lunch pretty quick, so do my best to help this go pretty quick. Basically, what we're going to talk about is managing infrastructure as code and kind of some of the things that you may not have thought about outside of running Terraform Apply just from a command line. There's obviously a lot that goes into it once you start actually dealing with real scale, and a lot of different developers, especially collaboration, can be a huge pain. So let's take a quick look. My name's Derek. I started with a lot of on-prem stuff, worked in managed hosting, blah, blah, blah. I've dealt with everything from Exchange, dealt with Ansible, Puppet, Chef, all of that. I've created some online courses. Don't know if any of you have seen them, but you ought to. I recommend them. And basically, as most of you probably know, I assume that's why you're here, you know that infrastructure as code has basically revolutionized the industry. It has absolutely exploded. ClickOps, of course, is fun to do. Your first time through AWS, it's wonderful, but at the end of the day, it's absolutely not scalable. It's possible to maintain drift and your state and everything else. Let's talk a little bit about those limitations. Now, today we're going to mostly talk about Terraform, since it is the most popular. CloudFormation, of course, is huge. Pulumi is big. But Terraform really is the elephant in the room. So resource management and cost, of course, is one of the largest issues, especially at scale. TF state management, since it does store pretty much everything that's important to your industry, secrets, everything else. That's also very difficult. Now, if you've got a lot of devs and they're all working from their local machines, you can have all sorts of issues. As we might have remembered a few years ago when AWS S3 actually went down for several hours, it was a configuration error, just one wrong command, basically brought down the internet. So it's not hard to do that, especially when you're letting everybody just kind of go cowboy on the CLI. It's kind of a big deal. This is just a little example I just grabbed from one of our blogs. Basically, infrastructure as code starts to get really complicated once you deal with a lot of stacks. Start dealing with a lot of state files, a lot of devs battling each other, trying to deploy different things that have different dependencies, et cetera, et cetera. So, as we kind of mentioned, client compliance can get kind of crazy with security. You've got different teams trying to work on different things, and you've got to manage how those teams talk to each other. You've got to ensure the security works, all of that. Kind of cover that in all these steps here. And then, of course, at the end, you've got cost. So I've got a lot of really cool tools that you can use. A lot of open source stuff out there. Spacelift actually utilizes some of those open source ones, if you'd like. But, of course, Spacelift does work pretty well. Not going to lie, I like it a lot. But really, the big issues you've got, automation is, of course, huge. Just running from the CLI is not going to work when you've got hundreds of thousands of lines of Terraform code. Policy as code is very important, ensuring that everything you run is managed properly and enforced and doesn't break any of the rules you have set. Collaboration, devs working over each other. Got a lot of pull requests, merge issues, conflicts, that type of stuff becomes quite a nightmare. Resource management and drift. Again, you get that one dev that decides to hop into the console and start poking around. Security group rules, things like that, becomes an absolute nightmare. Then, of course, as I've mentioned before, cost management. As we all know, that is a very, very, very big concern for most people. So some of the tools that you may or may not have used, GitHub, GitLab, Spacelift, of course, I love. Atlantis, Jenkins, those are really the heavy hitters in the industry. Jenkins is great. It's a little bit of a sledgehammer at times when maybe if you want a scalpel. Of course, you can do a lot of damage with Jenkins if you'd like, but it can also be used very well. Now, you've got policy as code, some of those tools. Open Policy Agent is great. TFSec is great. Sentinel, of course, is the Terraform or the HashiCorp managed policy as code. Gets a little expensive. You should start using that. Then, of course, you've got collaboration and accountability issues. As you can see there, some wonderful AWS keys. I'm sure at least one of you in here has seen that show up in a repository before. I know I have. Luckily, AWS let me off with a warning, but we don't have to go into that. So policy as code is pretty great to keep that type of stuff from happening. And again, accountability, that code history, maintaining all the pushes to your repositories, understanding who did what and how. Resource management, you can obviously use a lot of AWS tools, GCP tools, Azure, whatnot, to manage your resources, understand what's going on. You can analyze your state files using tools such as driftctl and Cloud Query that will allow you to see what has changed and what's caused it to change, and even who made that change, which of course is very important. And then we got cost. Infra cost and Terraform cost estimation are two of the main ones that you can find out there. Infra cost, of course, if you've used it, is phenomenal for taking a look at what's going to change and how much that is going to cost. So anyway, that's the slides. I'm not really a big slide guy, to be honest. We're going to hop in and we're going to do a little demo. Again, I'm going to use Spacelift, of course, because that's what's on my shirt. But we are going to poke around with like InfraCost and a few others. These tools are ones that you can use. You can actually bolt together your own Spacelift if you want to. I do recommend using us, but again, this will kind of show you some of the ways and some of the ways that people do manage their infrastructure. Let's take a quick look. I've actually built a fun, if it opens, there we go, I actually built some Terraform code. Not a whole lot here. We're basically just deploying an EC2 instance. Again, this isn't exactly a giant scale operation, but didn't really have the budget to launch thousands of instances here for a conference.
Can you make that bigger? Yeah.
I think I can. Yeah, let me take a look. Display settings. Yeah, that's what I'm going to do. I was just checking to make sure that I was in the right resolution. Yeah. Bam, there we go. Good?
Yeah, that's good.
Perfect. All right, so again, got some code here. What I'm going to do is just push that over to a repository that I've set up for that. We're going to use Spacelift. We've got a stack here that's set up. Let me make that a little bit larger as well. And what this stack is this stack is going to connect to that repository, and it's going to manage my state for me, which again, one of the most important things that you can do is manage your state properly. S3 buckets are great, but of course, as we all know, people do not like to put the right permissions on S3 buckets, and stuff gets leaked all the time. So let's go ahead and take a look. So let's just say I am a dev. I'm in my dev branch. Oh, we'll just change a thing. Let's just change the subnet here, I think. There we go. And my mouse is freezing, so 1 second here. Not something I expected to go wrong. So, I guess that's what I get for using a Mac, huh? There we go. Okay, we are going again. I think. Whew. Hey, Pavel, where'd we get these laptops from?
I've seen this with the embedded terminal sometimes.
Yeah.
Just open up a terminal and navigate to it.
Yeah. Yeah, it must just be with, I've been using this actually all day, so it must have something to do with the display. Or I just won't edit anything and just do an empty commit if I have to. It's not really a big deal.
For me, this is why screens became preferable.
I'm sorry?
You know, I blew up a demo and couldn't get it going again. That's why people go with the screens. It doesn't break.
Yeah. Yeah, I've actually, this is the first time I've used this laptop for a presentation and have never experienced this. So here we go. It's all part of the fun, right?
We're doing it live.
Exactly. I want to say the rest of that comment right now, but I won't. There we go. All right, we got something. I'll just do an empty commit. I won't even bother with it. Keyboard froze up. That sounds like a good name. All right. So we'll head back over here. So if I head to my repository, I've got my branches here. I can actually open a pull request if I'd like. And as we can see, of course, everybody knows how Git works, I assume. We've got our pull request right there. Create that pull request. And right now what's happening is Spacelift will check that out. We can actually go and see our PRs here, which is great. As you can see, it runs a plan, runs infra cost. I can see exactly what everything's going to cost right here in my output. So again, infra cost is something that is just absolutely phenomenal to use whenever you're dealing with multiple devs trying to push multiple things. Head over, take a look at my checks. We've got a cool little infra cost table right there ready to go so we can see exactly how much this stack is going to cost once I merge it in. So everything, as you can see, looks good. The plan was successful. I've actually got a plan policy right here that was written in Rego, which, from what I hear, is not something everybody likes, but I'm pretty adept at it at this point. So if we try to make anything too expensive, over $100, basically it's going to bomb the plan. Right now everything works out well though. I can head back over to my stack. And we can merge that request, confirm, and that puts it into main and starts our run. There we go. Infra cost is checked again. It will check against policies again, everything once again to make sure that it works. Shouldn't take too long here. Again, just a little EC2 instance. Should kick it off pretty quick. Perfect. Gives me an opportunity to confirm, make sure that everything's going to go well. You can also add comments on this if you'd like. Confirm that. You can actually see a history of the runs, which again, that comes to that accountability thing. We can actually see who is running everything. We know who to yell at if something goes wrong, something gets too expensive, etc. Now, if you're wondering how I'm authenticating the AWS, I've actually got a portable environment variable file here. Everything is, of course, encrypted, not just hashed, which is great. We'll go back over here to our run. Everything is applying just fine. Now, while that's applying, we've got another dev who's going to hop in there and start causing some problems. Let's go ahead and maybe we'll get lucky here. I just need this one file. Come on, just one file. I was thinking about it, but we're so close. We're so close. I'm going to hope we get lucky here. Let's go ahead and just kick out a 2x large and see what happens with that. Almost done here. There it is. We've got a nice little EC2 instance. Everything is ready to go. Then we've got the Cowboy dev. It is trying to deploy a 2x large, which again is against policy. Save that. Yep, everything finished perfectly fine. All good to go. We'll head back over. And we'll create another pull request. Make a little comment right there, create pull request. Let's take a look at the PRs and exactly what I was looking for. For once, a failure that I tried to include in this demo. So perfect. As you can see, our policy said, you know what, that was way too expensive. That is not going to work out at all. I'll run over to the checks. As you can see right there, denied by the plan policy, which is perfect. So again, something that is very, very important when you're running things at scale, ensuring that your developers are not going to start blowing everything up by themselves while, again, running Cowboy.
What feedback did the developer get? Just from the PR link?
Yeah, you can actually put the comments on the PR request, everything else, close it, whatever you need to do.
I'm sorry, would you say the policy was written in? What kind of?
Rego, R-E-G-O. It's an open policy agent, is how we do it. Yep.
Is that something new, or is that out of?
I'm not sure. A company called Styra, actually, I believe, does it. It's open source.
It's open source.
Yeah, it's open source.
This is the Untitled project.
Yeah.
2 years old.
Yep, so we can nuke that pull request. Oops, can't spell. So we can head back, playing by the rules again, creates that pull request. Leave that comment. And we'll head back into Spacelift. And as you can see now, everything works perfectly. Everything is fine. So merge it. Of course, we haven't actually changed anything, so it'll merge in just fine. And we've got our new run prepared. And everything should kick off just like it needs to. No changes, exactly like we expected. So, I'm not going to lie, actually kind of a short presentation today. I'm going to open up for questions. As some of you may have noticed in the brochure, I am still actually listed as Sean Odell. So this was kind of a last minute change. So I want to apologize for not filling an entire hour here. But happy to answer any questions you have. Talk some Terraform. Go ahead.
What happens if someone just runs Terraform apply just on their local machine? How does the state manage that?
It depends. Of course, they've got to authenticate. One of the great things about like Spacelift is you can, or again, Atlantis and a lot of the others, is you can actually manage who has access to that state. You can manage, like for instance, these contexts. You can ensure your developers can't create contexts or access these keys in any way. So you would definitely want to make sure that that developer didn't have any access from their console at all. They would push to Git, and that's really all they would be allowed to do. Yep.
So can you give us the 10,000-foot overview of exactly what Spacelift does?
Yeah, so basically we connect to your GitHub, Bitbucket, GitLab repositories. And we do these things that we just showed you. We're basically running runners behind the scenes, which you saw, which will run Terraform. We've actually, a little hush-hush, we've got Ansible on the way. We can run kubectl. We can do a lot of other things as well. Pulumi, CloudFormation, whatever. You can also set up your own custom runners to run kind of whatever you need to. But again, 10,000 feet, we're basically running and managing your infrastructure as code, allowing you to create policies around that, etc.
You want to go a little bit further and show us how you define a pipeline?
I'm sorry?
How do you define a pipeline?
Oh, sure. We can set up a new stack if you'd like. So basically, we have a concept called stacks, and each stack is connected to a state file. So create a new stack. Hop in. We're authenticated to GitHub here, so I can connect to any one of these repositories. Then choose your branch. And then you can also, of course, choose your project root. So if you've got like a mono repo or you've got a lot of different folders in one repository, you're able to do that. Then for the back end, you can choose. Y'all won't see Ansible right now, but we've got Ansible, we've got Kubernetes, CloudFormation, Pulumi, and Terraform primarily. You can also run TerraGrunt. You can mess with your versioning here. If you've got an old version of Terraform, hopefully you're not at 0.12, but we do support it. You can choose to manage a state here, or you can connect to a state file in S3 or wherever you'd like to store your state, but it is very convenient, of course, that we do manage that state.
Where do you store your state?
It's probably S3. Yeah, everything's basically managed. I think our entire stack's AWS, right? Yeah. And so the great thing about it too, this is you can define an administrative stack, which actually allows you to create more space-lift resources. We have a full-fledged Terraform provider that can do everything you see right here, just within Terraform. You can also set more advanced options, and you can customize, and this is how we got that InfraCost going. So we actually added the InfraCost API and everything that we needed and applied that during the planning phase. So you can add different hooks you need. If you need to reach out to a vault or something like that, you can do all of that here with these custom hooks. And then basically just name it.
So how do you get, can you get the drift, one of the drift tools integrated in your tool also, or does that come through?
We do have drift detection enabled. Unfortunately, I didn't have a chance to get that set up with this stack, but we do have drift detection, and you can basically you set up a cron job. Within it, use cron expressions to determine how often you want to run. And what it does is it runs a plan against your stack, and then you can set it to auto remediate if you'd like.
Does that work the same way for CloudFormation? Do you use CloudFormation kind of drift?
How much do we have CloudFormation drift?
Well, CloudFormation already has the.
It has drift detection. It doesn't have the remediation, if I remember correctly. Right, but it does detect for sure. So yes, we do have that in as well. Oh, sorry.
So can you like chain multiple stacks together? So let's say you want to start one
Yes.
first and then
So can you chain multiple stacks together? Sorry, I keep forgetting to repeat your questions. Yes, you can. You can run trigger policies. One of the main things we're kind of seeing, again, with this Ansible rollout is a lot of people like to perform configuration management after they've run a Terraform stack. So you can set it up to automatically trigger another stack as soon as Terraform is done. It will, for instance, trigger Ansible to access that stack and configure whatever EC2 instances you've launched.
Would you mind walking us through that Rigo policy?
Sure. Let's take a look. Yeah, so basically right here, walking through this Rigo policy, we've got our deny rule first. We've got a threshold set here, pretty straightforward. So what it does is it accesses the plan, and it parses that plan. Threshold here is set at 100. Monthly cost set right here, and what it does is it allows you to access that plan, which you can do in our Rigo builder. We actually have a Rigo builder that allows you to dive in and access an existing plan and test different policies, which again is very helpful. Got a deny there, and then we also have a warn, which has a much lower threshold there. As you can see, if you get a warn, you'll pop up a warning, it'll add a comment, you'll see that it happened, but you can, of course, push it through if you need to. We've got this sample down here, and what that sample is does it allow you to take a look at it after the fact? And let's go and take a look. Take a look at the logs. All right, so we've got the plan policy here. That sample flag basically allows you to hop in and start analyzing it based on the input stack here. Now, we do sanitize most of the attributes that come out of a plan, but we have a function that you can use, basically an unsanitized function that will allow you to access these attributes whenever you need to. But you can kind of cut through this entire state here, and you can play with the different attributes, everything else, and you can hit simulate, and it'll tell you whether it passes or fails. All right. Any other questions? All right. Well, y'all want lunch? I think my team, they said they'd buy the whole room lunch. Is that right? Depends. It depends on which caviar you want. I hear Russian's kind of tough to get nowadays, but you could probably find some.
If you guys have any kind of questions regarding the problems you're facing managing your on scale, so we do work with a lot of customers, happy to share our knowledge.
Yeah, anything? All right. I think we're all set. Thanks.
rather than asking people to do. Oh, congratulations, team. GitLab won the SoCal Linux Expo list most interactive group award. All right, copy. I'm still talking to the mic. Check, check, check. Last day at Scale 19. Sometimes the question of people who don't contribute as much is, can we get them to do more? Instead, we should. Okay. My favorite part of my talk at Scale 19 today, in an hour in the Marina Room, is a personal note that says, Q ...
Test. Ooh, it works. Yes, this is the session you want to see. It is. This will be awesome, I swear. Everyone in here is really excited about it. See, now I've kind of like forced him in because he's like, oh, now I have to commit. See, my evil strategy's working already. Oh, see, there's someone else wandered by the room. You can come on in. There's plenty of room. Saved a seat for you. She kept on walking by. I see familiar faces from my last talk, so I must have not scared everyone away in the last one. That's always good. It's a good feeling when you don't scare people away. Almost at the start time. All right, well, we can get started, everyone. Thank you for coming. I appreciate it. This is going to be an unusual talk, so this is my public service announcement. I've given this talk once before. It's an unusual talk because I'm not actually talking about, fixing anything. I'm not talking about databases specifically. Oh, you want to come in? Yes, we have a seat just for you. See, it's just for you. We saved all these seats. Yes. See, now he's committed. Like I said, see, it works. So this is a bit of an unusual talk because this isn't really about any one specific topic, but it's a collection of stories, and there are things that we see in the real life space that really have some commonality with things that we do in the tech space. So for those of you who haven't heard me talk yet, I'm Matt Yakovit, head of open source strategy at Percona. So we do open source database software and services. If you're interested, you can follow me on Twitter. You can check out the podcast, The Hoss. That's me, head of open source strategy, talks FOSS, free and open source software. It rhymes and everything. That's cool. So that's awesome. So you should check that out. So I wanted to start to tell you a little story about something that happened to me this week. So I have a 20-year-old daughter who's soon to be 21. She works at a veterinary clinic. And I dropped her off last Saturday, and like I normally do. And so about an hour after I drop her off, I get this text. Okay? So I don't know how many of you have kids, but when you get this type of text, you generally don't know how to respond initially, right? So, hey, can somebody get me, I might need to go to the urgent care. This could be something that is small, it could be something that's big, so naturally you don't know how to respond. But when you say, I might need to go, there's some doubt there, right? So it doesn't really have the sense of urgency, so okay, let's investigate further. Of course, we investigate a little more. What's wrong? Oh, a dog bit me pretty good, and it did break the skin. Now, my daughter gets bitten probably 3 times a week by dogs, generally not that bad, but she does get bit in her line of work. Okay, so I'm on my way. So it doesn't sound terribly urgent, but you do have some concern. And so me and the wife pile in the car, we drive the 5 minutes down the road, and then we pull into the vet clinic. What do you think that we saw at the vet clinic? Anybody have any guesses? Well, I'll tell you what we saw. So we saw animal control because, hey, it's a dog bite. Okay, that makes sense. But what didn't make sense is the 2 police cars, or the ambulance pulling the stretcher out of the back, or the fire truck. These are all things that you don't want to see after you get that text, right? I mean, I don't know if if you're different, but when you pull in and you get a text that you are supposed to come pick up someone and, not that sense of urgency, but you see all that, you kind of freak out a little bit. So, of course, that heart attack pain, you're like, oh my gosh, I thought it was the cheeseburger's going to kill me, but no, it's this because it's so stressful. And so you freak out, your level goes all the way to 99 and you're just, horribly upset. So you park sloppily, you jump out of the car, you run inside, and you talk to the tech people and you say, oh, is this for Carly? And they're like, wait a minute, no, stop freaking out. This isn't for her. It's for the other person who got bit. So wait, there's 2 people who got bit now. Yes, there's 2 people who got bit. Okay. Well, yeah, so the other one's worse. So Carly comes out and she's bandaged her arm up and she's walking out with the fire chief. And the fire chief says, well, hey, she's going to need some stitches, but you can take her. Okay, so we get her in the car and she explains she's really upset. She hopes they don't do anything to the dog. She's more worried about the dog than herself. So, you start to calm down and she says, yeah, the dog. I love the dog. The dog's name is Chaos. It really is chaos, and so she loves chaos and she doesn't want anything bad to happen to him. So by the time we get to the hospital, everybody is a little bit calmer. Okay, so dog bite wasn't maybe as bad. The other person seems to have gotten it much worse. Thank God we avoided that. And so we go into the emergency room, we go into the back, and they unbandage it, and then it's like, oh, nope, it got worse. Because you start to see the things that you don't want to see sticking out, and you're like, oh, no, that's horrible. And so, of course, you pass out on the floor, and then they revive you, and then we find out, oh, you know what? It wasn't nearly as bad as it looked. So now we have gone back and forth, and she's gotten some stitches, got a few days off work, and she's back at work. So that was my weekend last weekend before I came here. So this weekend's a little better already. But my question to all of you is, this happened to you before? Has anybody else had this happen? Well, maybe not this exact thing, but you do, right? So as we've written software, as we've designed new applications, how many people have written kind of sloppy error messages or alerts in their pipelines, or have put out things that really don't, put off the sense of urgency on why you do things, right? Because we, often think that, this will never happen, and when it does, I'll figure it out very quickly. And so you'll get an alert that says something like, oh, by the way, this, service is down. We're going to try and restart it. And you're like, oh, okay, I'll just let it go. And then 10 minutes later, your boss calls and goes like, oh my God, the whole website's down. I can't get to anything. And then you're like, well, but my text or my message didn't say anything about it. And then you go debug, and then there's some, innocuous line like that says service trying to restart, and that's all it says, right? Oh, see, you've had that happen. But that's where you have this type of thing happen. So that initial text, that initial, response, it doesn't give the sense of urgency. And so, honestly, I wish I could reprogram my daughter to say like, hey, if you need to go to the hospital, it should be like, help, take me to the hospital now, or something like that, because that would send the sense of urgency as opposed to, like, come on, I think I might need to go, I don't know. So we want to see, that type of thing as we're designing things and building out applications. Now, the fun thing is, that's an actual example that just happened. So that was added this week. You are the second crowd to see the rest of these slides. So thank you for beta testing. But there are awesome good and bad practices for all kinds of design principles all throughout the world. You just have to know what to look at it. And maybe I'm just a weirdo when I look at things and go like, wow, yeah, I designed something like this and this is horrible. Or, wow, I should use this example in my, real world work. So a lot of these examples, come from people who are just trying to copy other things. A lot of us copy other tech companies, but we're not comfortable copying non-tech companies, right? How many people go to sessions and listen to Amazon or Meta or Google or Microsoft? They'll tell you how to develop something cool, and you'll be like, okay, I'm gonna go try that, right? You do that, but you never go to McDonald's and say, I'm gonna try to do this like McDonald's does. But you could, and I'm gonna tell you why you might want to in a second. So let's talk about, a few different things. And these are going to be rather random kind of conversations, so it's going to, jut around a little bit. But I want to start with talking about the responsible selection of tools and components when you're looking at building out a stack, okay? And so where do I start with that? I start with the children because they are our future. Now, how many people here have kids? No judgment if you do or don't. I don't like to admit that I do most of the time. Maybe if you don't have kids, you also can commiserate with this because kids are annoying, aren't they? There's no kids in the crowd, so I can say that. Yes, most children have times where they are awesome, but a lot of times where they just drive you absolutely nuts. And so what do we do with children who drive us nuts? Does anybody know? We distract the children, right? With TV shows and with awesome things. We try to make them see the shiny objects to let us go do whatever. Okay, this is a secret for those who don't have kids. When you do have kids, you will totally understand this. Now, for me, and growing up, I was very different than my daughter. So I had the cool cartoons, so I got the Transformers and the Thundercats and G.I. Joes. Unfortunately, my daughter grew up with Teletubbies and Barneys, which was just more annoying than not. But the thing with these shows is they really feed into that, kids, imaginations. They really feed into what the kids are looking for. And, it turns kids a little bit into lemmings, right? Where they're going to follow that trend, whatever their cool kids are doing, whatever the trends are happening, whatever fads are going. Now, Furby was big back in the day. It's not as big now, but, there are lots of fads that come and go that become popular. Now, some of them do become iconic, right? So I can actually sit down and stomach SpongeBob even today. I can admit that. I have watched SpongeBob without my daughter. That does not make me a bad person, okay? Doesn't make you a bad person either. But when we talk about choosing tools, choosing libraries, choosing frameworks, it's a similar situation where, we all love cool things. Who does not love to listen to a session on new technology and something awesome that they've never heard before? And who wants to go out and try it in production? Right? I mean, I think we all do. We want to see what happens. morbid curiosity, if you will, right? And so, here's the fun thing about that, though, is number one, we really have short attention spans. So I don't know about you, but me, I start things and I'll start to learn things and I'll get halfway through it and then I'll be like, okay, time to go learn something else, right? If it didn't pique enough interest, I'm gone, okay? The problem is a lot of people do that in the middle of projects. So they start with one framework, they start with one project, and they go to the next, right? And so you end up with this weird sprawl, this tapestry of uniqueness in an environment that is just strange, right? And what's fun about that is a lot of these, are really hard to hire for. So if, think about like the latest technologies and trends, I don't know, maybe you're into Haskell. How many Haskell programmers out there? You've got a few Haskell programmers. It's hard to find Haskell programmers, right? I'm not saying Haskell's bad. It's just, it's hard to hire for when, new technologies, new trends come along. But these development tools, they come, they go, and how do you handle these, right? And, it's that, herd mentality where we want to follow other cool people who are doing awesome things, not all trends, though, are going to last. And I want to tell you, it's okay to be nostalgic. Old school cool is a thing. So you can choose technologies that are tried and true and still be cool. That's something that's, important to realize. I give you permission. But remember, those trendy things do come and go. I'm old, so I remember, everybody was all Adobe Flash. Nobody even mocks me for that anymore. Hardware appliances, the network is the desktop. Remember the Google Glasses were going to replace everybody's phones, right? All of these trends happen and they go away, right? So these are things that are happening on a regular basis. So just be mindful when you are choosing your technologies. Is this going to be Barney the dinosaur or SpongeBob? Okay? Because it is a critical distinction. It really is. Now, when you do choose those components, okay, we are all here at a conference that loves to celebrate open source. Most of the stuff here is open source. But my challenge to you is, as we choose these components, which version of open source are you choosing? Now, I had the fortunate or unfortunate circumstance where I was in Vegas for 4 weeks last year, or maybe it's 2 years ago. It was like conference. It was just pre-COVID, so it was a couple of years ago. And so it was like, after 4 weeks of Vegas, your brain starts to do weird things. Okay, I don't know if anybody has had their Vegas brain just do weird things, but of course, when we talk about open source, I was thinking about this as I was wandering the Vegas Strip and as I was trying to find some place to eat. And of course, what is Vegas known for? The buffets, right? So many buffets, so little time. And after 4 weeks, you don't want any more buffets. You're just, please, no, I don't want any more. But, you have so many different choices of buffets that are out there, right? You can get the free all-you-can-eat when you go to certain hotels. Other ones, you get the free continental breakfast, but if you want the eggs, then you got to pay extra. The other one is, you have the free, with the minimum drink purchase, or buy 3 buffets, get 1 free, you could pay per pound. There's all kinds of different ways that these buffets advertise, but all the buffets eventually do have a cost. And why this struck me as so weird is this is very similar to the open source, ecosystem right now, right? So you've got the pure open source licenses like Apache or MIT, and it's the free all-you-can-eat buffets that you can go and you can consume as much as you want and do whatever you want. But then you've got Open Core, which is that continental breakfast, but you pay for the hot bar, right? And then SSPL, which is you're open with restrictions. So when you have a company like Mongo or Elastic, where it's hey, you can use our stuff for free if you pay for something over here or you follow these specific restrictions. Exit the gift store on the exit, right? Or exit through the gift store. The source available license, which allows you to look at the buffet before you purchase. Or the eventually open buffet, which is you buy 3 buffets and then you will eventually get 1 for free. Or the freemium SaaS cloud, which is you pay per pound. So that's the cloud model, right? So you pay per pound of food, you pay per instance, you pay per instance hour. And then, of course, the open source compatible, which is saying, hey, that buffet across the street, we're just as good as them, but you should pay us. Right? So they are all over there, and we have so many choices, okay? More choices than ever. And Just like there are some weird fusion food choices out there, we have that with the buffet option of licenses as well. And, we have too many providers trying too many things. So you have to understand what sort of license you have and figure out where you're eating off of that buffet. So important to not follow all the trends, but also if you do pick on technologies and you do choose components, you should make sure you're choosing the components that are fitting to your buffet lifestyle. Okay, now that we've picked some components and we're talking about building an application, we're talking about building something, let's talk about success criteria. Now, how many people before they've designed anything think success? What does success look like, or what's my requirements, or what's the outcome look like, right? Some people do, some people don't, right? But how about when you build a house? What do you expect when you build a house? Okay, you probably have some expectations, right? That's reasonable, right? That it doesn't fall down, that you can live in it, that you can get electricity, that you can, use the plumbing, whatever. And so this is a house that I had purchased a few years back. And brand new house, builder spec, beautiful home, had all of the appropriate number of fixtures and everything else. And so we moved in, and when we moved in, everything was perfect for the first couple of years. About 2 years in, we started to notice in the bathroom, one of the floors started to buckle a little bit. And we're like, oh, that's weird. So we called up a plumber, and the plumber said, oh, by the way, your bathroom has a leak underneath the floor because they forgot to put an O-ring on the toilet. Okay, so it worked, and it worked okay for 2 years, but in the end, it didn't work, right? Because let's be honest, when we say, ship it, it works, it's not a good thing, right? So yes, the toilet flushed, yes, the plumbing worked, but it's not enough to just say that it works. And that's where there is a completely fine line when we think about success criteria, right? Where is that success? What does it look like? What are we looking for? And it works is never something anyone strives for. It's something we all compromise to. Right? I mean, how many times have you been, working late night, annoyed on some, bug or something, and finally it just compiles, and you're like, done, and I'm going to go to bed, or I'm going to go out, and I'm going to do whatever. And it works is great, but you want it to be at least it works and it's good enough to be sustainable, right? That's an important distinction. You want it to not fall apart within a year or two. You want it to not just be that, ugly mess of an issue that's sitting underneath the floorboards, getting all gross and ready for someone to come and rip it all out and start over again. Okay? And even if you are focused on good enough, okay, I want to leave you with this thought here on this point, which is, while an idea can inspire you, a good enough project generally isn't going to be something that's going to lead to commercially viable success either. So if this is part of somebody else's infrastructure, maybe good enough is okay. But if you're building your own product, this is your lifeblood of your revenue stream, it's something that you're going to want to make sure that it's better than good enough. Okay? The internet is littered with projects that are good enough. If you go to GitHub, there's a lot of projects out there. Do you know how many projects actually make money and people are like, woo, I'm rolling in the dough? Not many. So keep that in mind as well. Now that we've decided on building some foundations, we've decided on success criteria, what comes next? Well, there's a lot of different components, but I like to talk about concurrency and scale. Ah, yes, concurrency and scale. So when you are building a system that can handle millions of users or billions of users, who should you look to for an example? You might say Amazon, you might say Meta. I'm going to tell you to look at the fast food industry. Yes, because guess what? McDonald's does serve billions and billions, but I'm going to talk to you specifically about Chick-fil-A. Now, how many people here have been to Chick-fil-A? Oh, come on. We all know that you love Chick-fil-A. So I gave this in Amsterdam, and no one, I was like, what's Chick-fil-A? You don't know what Chick-fil-A is? Oh, my gosh. So think about Chick-fil-A. Let's start with how they design their menus. They are simple, uncomplicated, right? They have chicken. You can't order a burger. You can't order a hot dog. You can't order pizza. You can't order, like a multitude of things. They have a few common components, and they make those components reusable across all of their different items. And so that means that they can get an efficiency of scale. So in the back, they know how to make a chicken sandwich. They know how to put the chicken chunks in the box, right? There's not that many components, so they have optimized for that. But where their truly unique genius comes into play is in the drive-thru, okay? Now, how many people have been to the Chick-fil-A drive-thru? Okay. How many people have seen the Chick-fil-A drive-thru like this? Yes. Oh, so you don't go, right? Because most people will turn around. In fact, some Chick-fil-A drive-thrus look like this, right? Because they are popular. Now, here's the fun thing. Most people look at a drive-thru like this and they're like, nope, I'm going somewhere else. I'm going to McDonald's. But Chick-fil-A has this weird thing. They have designed their queuing system, their drive-thru system, to solve scale problems. So if you see a line like that, you're going to get out in 10 minutes or less. And that's weird, because it doesn't matter how long that line is. I can get in the back of the line and go like, oh, I'm going to wait forever. It's going to be 10 minutes or less. And they have this really, unconventional practice where they'll send out workers into the lines, and they'll take your order, and then they'll run your orders out to your car before you even get to the drive-through window, before you get to the order-taking spot, right? So they're trying to optimize the entire process. In fact, excuse my, 3-year-old drawing. This is my, 3-year-old self trying to draw what a Chick-fil-A, drive-through looks like. But they do multiple lanes. They have like a fast lane for call-ahead orders. They have mobile order takers where they'll run out, and then you could park over here, and then you can have them run out your food. So, they have optimized this process, for those long queues to be able to scale. And in fact, this has been so successful, I don't know if anybody saw this, but the governments, city governments, state governments, started to ask Chick-fil-A to come optimize their COVID testing lines, right? I don't know if anybody had to do those mobile COVID testing where you're just like in the line for like 12 hours. They're like, oh my God, this is a mess. You know who we need to call? Chick-fil-A. That's right, Chick-fil-A, because they know what to do, okay? But when we look at this example, they tell us a lot about things we should do. Whoa, that is just weird. Woohoo, look at that thing go fast. See, okay. Yes, poltergeist in the system. So what can we learn from this, right? So we can learn a lot from the system on the system side. Things like, hey, we should pre-validate our requests, right? So they're running out and they're, ordering from the lines ahead of time before you actually get to the place where you're supposed to order. They're pre-fetching your food and running it out to you. Okay? Just like we should be pre-validating our data needs or what we need, we should be doing as much as possible. Okay? They speed the delivery of data, right? We need to do that. Segregate different types of requests when we're building the application, right? Don't have everything go through a single channel. If you need something that is immediately, time, bound, have a queue for that. Have another queue for something else that's slower. Have direct access if you need it, so you can bypass some of the overhead, okay? Know when things are slow, you can always make changes, so have the flexibility to make those changes. Because the thing about that queue with Chick-fil-A, they shut down lanes when they're not busy. They don't send workers out, so they know as soon as you reach a certain level, they span up, they shrink down. Kind of sounds a little like some of our, architectures now, right? When we're talking about the cloud native space. So you can learn a lot by looking at how some of the real world examples like Chick-fil-A build their systems, because there is a mirror on how we should be building systems to handle the same sort of traffic and workflow. But we all know that even if we're building it, we're all moving faster than we ever wanted to. I know like no one ever says, oh, just take another 3 or 4 weeks to get that deadline done. We're good with that, right? They're always like, we need it sooner rather than later. And so we have this, move fast requirement. And that often has unintended consequences. So look at, the growth of industrialism, all right? Yes, I'm working a lot of different references into this talk. Impressive, right? So when we look in the 1800s, and we look even, into the last century, the amount of progress across the world has been insane. And it's all been driven by industry. It's been, driven by factories. It's been driven by new innovations. But one of the consequences that happened, and it really came to light in the 1970s, especially here in the US, was the pollution that a lot of this was causing, right? So we had rampant pollution. Now, anybody here from Cleveland? Anybody here ever go through Cleveland? Okay. Have you ever heard the term the mistake by the lake? Okay, well, they used to call Cleveland the mistake by the lake. The Cuyahoga River in the 1960s and 70s looked something like this, okay? So, this is one of the crazy things, like, ooh, we got a beach over here, and yeah, I don't want to go swimming in that. So what happened with this is they've had so much industrial work. All those are factories down here. They call this the factory district along this edge. So all these factories dumped all their pollution into the water. And, they had a problem. And one of the problems was with fires. But it was fires on the river, right? Not once, but a dozen times, okay? Like, I don't know about you, but when I hear a river caught a fire a dozen times, that tends to tell me that there's something seriously wrong with that. So it's that unintended consequences, right? You really don't want the river to burn. Okay, so we have that, but I like to take this PSA real quick. The law of unintended consequences. Anybody working on machine learning AI stuff? Okay, a few. Yeah, please don't make Skynet. Thank you very much. Okay, now, how do we go through and clean the rivers? So there was not only pollution and garbage in the rivers, there was also a whole bunch of invasive plants that started to, show up. And so a lot of enterprising or really smart scientists came along with this idea. We should use something natural to clean up the waterways, as opposed to trying to do something that could make things worse. So, what's really good at getting rid of garbage in the yard? Goats, right? They eat everything, yes. So we know that goats could be lawnmowers, and they can also be, effective garbage cleaners. So, how do we do this for the water? Anybody have a guess? It's carp! Enter the carps, yes. So in the 70s, they introduced carp to help clean up the pollution, eat the garbage, eat the plants, eat all kinds of other things. But, these really smart people didn't actually see one potential big problem. That is, carps like to eat. And they don't stop eating, and they're not limited to eating the stuff that you want them to eat. They will eat everything. And so we actually have a pretty bad issue right now where we've had invasive carp that are killing off all of the native fish. They're destroying the ecosystems. And it is a horrible, horrible problem. Actually, some people say it's worse than the pollution problem. Okay? And so how do you deal with this? That's a question we haven't solved yet. But this is really an interesting case study in, thinking about tech debt and tech regret, right? Because we often have solutions out here that we're like, okay, we need to solve this problem. This is a problem that is real. How do we fix it? And so we go out there and we find the new widget, we find the new software, we find the new library, we find some new way of doing things, and we decide, we're going to introduce this. Without thinking, could this make our systems measurably worse? Right? And so we'll introduce that into the ecosystem, and a lot of times it just doesn't work right. It causes more problems. And there is, a process you should go through before trying to solve these problems. It's think about what these, new solutions, what you're going to try and do, what's the outcome going to be, what are those potential unintended consequences, and what you're introducing. If you're doing another integration, you're introducing some new technology, some new thing, has it been vetted? Who else is using it? It won't always work for you. How do you control this? And there is a difference between tech regret and debt. Okay, now, anybody here understand the difference? I can explain. So tech debt is something that is, isn't going to scale and is broken. Tech regret is where I just feel that I can do better, and I'm disappointed in the work that I have done. Okay, so there is a difference between the two. And tech regret is that process of thinking like, ooh, I wrote that code when I was, 10 years ago, and my God, if I knew what I knew today, I would write it differently. And you know what? I'm going to redo it. It's not always a good thing because sometimes you can't, capture that magic again. Like I love movies, okay? I do. I don't know if anybody else loves movies. I love movies. But you know what? Sequels to most movies aren't that great. I don't know. Teen Wolf 2, anybody? No. Jaws 3D? No. Just not great. But there are some ones that are better. And so the question is, if you are looking to revise or fix things, is it because you are regretting what you built and you think you could do it better? Or is it because you actually have an issue you're trying to solve? Because those are two very distinctly different things. I mean, I'm tempted to redo a lot of stuff that I do. That doesn't necessarily mean I should do it, especially if it's working and meeting the customers and the user's needs. Okay. How many people have ever gone back and then rewrote something completely because you just weren't happy with it? Okay, a few people. Okay. How many times have you done that where someone who's using the product doesn't even notice? Or if they, they're not getting any new features, right? It's like, yeah, they have no idea what changed, but I spent a year and it is way better. Good use of my time, right? So will it enable the users to have some benefit? Is this going to be worth it? Those are questions you have to ask. And it's, similar to back when you have the pollution side of things, that's a tech debt that you need to solve. Okay, so that needs to be resolved. But when you talk about regret, that's saying like, oh, I wish I would have done something different to fix it because, yeah, it's a bigger deal. Now, the CARP, on the other hand, that's also tech debt and regret together. So there you go. I regret what I did. Now I really need to fix it. So how many people have bought into this new concept called Devops? Oh, yes, the DevOps. Yes. So let's talk about the best DevOps example that there is, the Cold War. Yes, this is the epitome of awesomeness for DevOps and automation. Of course it is. And I'm going to talk to you about that dark time of our lives when we all lived under the fear of nuclear annihilation. Yes, that wonderful time when Strategic Air Command was all the rage. Now, if no one is familiar with what Strategic Air Command is, let me give you a rundown. Strategic Air Command had the responsibility of being able to blow up anybody within 15 minutes. That's their job, right? So, they decided that they were going to have lots of different locations, and they were going to be able to get anywhere within 15 minutes. They had to have tens of thousands of employees distributed all over these bases, and they had to be responsible for the most lethal killing thing in the entire world. Okay, so they had a pretty big job. But the problem with Strategic Air Command was, initially when they launched it, they started to do these very routine tests, and they found like, oh, they got proficient on everything because their test was something like take off and land. That seems like a good thing, like taking off and landing. But then they really didn't test anything else. So they found out, like when they started to increase the tests and what they were looking for, that they were good within a 5-mile radius when they were going to drop a bomb. So somewhere within 5 miles, they could hit, which is probably not as accurate as you want it to be. But they also found that they couldn't get anywhere in the world in 15 minutes. It would actually take them about 3 weeks. Kind of defeats the purpose of the whole thing. So they brought in Charles Lindbergh, of all people, to sit down and evaluate, SAC and said, what's wrong? And, he came up with these 4 issues, right? Inflated scores on exercises. So as they did those tests, they were getting like all these great reviews, and they were completely controlled tests that had no real world applicability, right? They never tested what happens if an engine stops running, what happens if like the plane won't take off, what happens if, like you are missing crew members, so all kinds of different things never occurred to them. They also didn't have any sort of accuracy, like I said. They also had this insanely high accident rate, right? So people were dying within just test flights and stuff. And things were falling apart because no one actually maintained the systems and no one actually maintained the planes. They would just take them out for their test runs, and if they flew, then wonderful. And they also had almost no routine and preventative maintenance. All right? So they had some pretty significant issues. So they brought in this new general to take ownership of this, and he really started with this philosophy of, first, consistency, standardization, and leadership from the top, right? So we want to work as a team. We want everything to work together. So leaders and crew are all part of the same, group, and they should be treated the same. No one should be treated differently. But we're going to have checklists. So when we talk about those failure rates, we're going to have 600, different checks. Now, how many people have gone to the airlines and, you've flown recently? Maybe you flew here, and you see the pilot, and he's got the clipboard. These are checks that they started back here, okay? This is how, flight started to, get standardized. So they check everything to make sure it works. And they also introduced different tests, a little bit of chaos engineering, if you will, into the system where it's like, hey, it's 2 a.m., everybody get up and get on your plane and take off, right? So we were looking at ways to see what you could do to increase, that consistency and efficiency. But they also built everything for repeatable scale. So knowing that they would have to potentially fight in a war, they started to make everything universal. So it was like, oh, we want every missile silo to be the exact same, because if the power goes out, then people know how to get around because they won't have the lights. And if, there's smoke in this, then they know how to get around. And if they know where the parts are, they can go get the parts. They know where the generator is. So every missile silo that they built was the exact same, had the same process. And everyone was able to train on anyone else's job so they could fail over people in the case of an issue. Now, when we look at this and we look at the parallels in the, current market space, right? I mean, how do you draw a Cold War back into the, current, infrastructure space? We talk about automation, we talk about process, we talk about checklists, okay? But we still know that these still have failures. But we have built the systems to go through and check our tests. We're doing, a lot of test-driven development. We're doing, automated testing. So we're looking for those problems that occur. We're doing our own 600-point checklists, but we're doing it automatically. We're also reusing a lot of our components. As we start to use microservices, we're trying to copy the same infrastructure so we can have that consistency. So when there is an issue, we know how to fix it. When there is a new release, we know that it is rolled out to everybody else. We also verify that every one of these things is following the process. So we focus on that verification, and we hold, each other accountable that way. But, there are some things that we don't do, right? So one of the big things that we've seen rise in the last few years is chaos testing. And that's something that we haven't done enough, oh crap testing, right? This is not something that's good, But we do see that people do take, those types of tests seriously when they do them. So these are the types of things that we can learn from, this particular space. Now, a few final thoughts. Look, we're all designing new systems. We're all looking for inspiration from everybody else. It's great to come to a conference here and listen to how other people are talking and doing things. But, hey, as you're driving through the drive-thru, as you're going to get your coffee at Starbucks, as you're looking at that river that's on fire, you can gain inspiration from those, and you can figure out new ways to potentially do some really cool things. There are tons of great examples out there. And one of the great things about these is a lot of times, I don't know if you get this, but you talk to somebody who's not in the tech space and they're like, oh, you work in tech, can you explain to me what you do? And you're like, no. So you can take these lessons and apply them and talk to people who might not be as technical and show them oh, how this thing happened? Yeah, that's what we're trying to solve. We're trying to prevent the river from catching on fire and not releasing the carp. But it is something that you need to be mindful of. And so think about these types of things and, hopefully you found it interesting. So we can learn from all those examples all around. So That's my talk for today, everybody. I hope that you appreciated this fun ride through history and complete nonsense. Okay. So the question is, should automated testing be augmented with manual testing? I do think that once in a while you should go through some manual tests, yes, because I think that we rely too much on automation to save us, and it often overlooks some minimal things. So I'm not saying you have to manually test every week, every quarter, every, so often, you have to do something, right? Like for instance, testing backups. I'm a database guy, right? So we often just script the backups to run, but we never test them. And so you don't necessarily understand what you're seeing there. So going through that process of, testing things manually as well as the automation, it's a good practice to go through a couple times a year maybe, or maybe even more often than that. It just depends on what your application is and how big it is, right? I don't think you can do it at mass scale, but there's so much that you can overlook if you're not, looking at, because you're focused just on the tests you've written, and if you haven't written tests for it and it's causing an issue, then how do you catch it, right? You wait until somebody catches it in production. So, yeah. Any other questions? Cool. All right. Thank you very much. I hope you enjoyed this. You are beta crowd number 2 on this talk, so hopefully you liked it.
Check, check. Test two, check.
Sounds good. Enjoy. Can you, I mean, I guess somewhere up. Hi, everybody. We're still a few minutes from getting started, but feel free to grab a seat. Feel free to grab some ice cream or some coffee or some snacks from the back of the room as a sweet way to end Scale. So if you are in the back of the room, again, there are plenty of seats. Come grab a spot. Even socially distant, we are good. And again, enjoy some ice cream in the back of the room. We'll get started promptly at 3 o'clock, which is just a few minutes away. This is a giveaway for some of the activities we did in this weekend. These winners. Yep. Good afternoon, everybody. I know we're all super excited for the presentation in just a moment, so I'd ask if we can start to settle down, start to grab some seats. There is not many sessions that will pack a room at 3 o'clock on a Sunday. I know we're all super excited about this one, so thanks for coming out. Again, at the risk of you all running out of your seats one last time, which I don't encourage, there is still some ice cream in the back of the room for those of you that are looking for some. Okay, maybe it's gone. There is definitely some coffee and some other things. Again, thank you to our amazing break sponsors that supported the event. VMware, Mattermost, and I'm blanking. This is what happens after 4 days of being here. I will get that in a second, and I will thank them. Hopefully, they're not watching the recording. Databricks, yes, sorry, Databricks as well. So thank you again. We are super excited to have everybody back here together after that 2.5-year break. For those of you that were here in the morning, it's maybe closer to a 4 or 5 hour break, but thanks again. We've got a few administrative things, and then we'll go ahead and get started with our main attraction with Dr. Sir. So how many of you participated in the expo floor passport program / scavenger hunt? How many of you feel like you got all the answers right? Okay, much fewer hands. Turns out only one did. And he was tenacious in doing so. He was tracking me down, asking me for suggestions, tips, trying to figure out if I knew the answers. I did not, because I didn't put together the program and it looked hard, so I didn't personally do it. I also don't think I'm allowed to give myself a prize. We've actually got, I see him in the room here, so Kyle, do you want to come join me on stage and tell us a little bit about what they have won, and then I will tell you who it is.
Hey everybody. So what we have for the Raffle Winner today is a fully decked out Librem 14 laptop with, what makes it special? So one of the things, so when we made it, we looked into what are all the things that we learned from all the past laptops we made that we think would make this our dream laptop. So in addition to having hardware kill switches that shut off kill the webcam and microphone and the Wi-Fi and Bluetooth, it runs core boot firmware. It also runs in open source embedded controller firmware as well that we developed. And in general, it's just like the best laptop that we've been able to make so far.
Thank you very much, Kyle. I'll give you one fun fact on Kyle. Kyle is the only Scale speaker that I know of in the last 20 years that we've been running the conference to have a literal explosion occur in their talk. Please, I know it might sound hilarious, but please don't leave cans of Coke directly behind the hot fans on projectors in the session rooms. I'm sure nobody intended to do it, but it made for a fun surprise for Kyle and a sticky situation for the hotel. So I'll stop keeping you all wondering if you won. The one person who did win is Dr. Sam Coleman in the back of the room. Come on up. And for those of you that don't know Sam, you've been coming to Scale since what, 2004? 2004? And you were, at the time, you helped us run the education track, among other things, if I recall correctly?
A time or two, yeah.
Open source software and education. And so at the time, I don't think you were Dr. Coleman. At the time, I think you were just Sam.
Just a random dude.
But congratulations. I hope you enjoy this free software-powered laptop, open from, again, courtesy of the Purism team. and Kyle. And before you take off today, we'll want to do a quick picture for the Purism folks as a thank you for that. Awesome. So again, thank you for coming out for the closing keynote. This is the first time we're doing this, but we thought it was an important opportunity given we had such an auspicious speaker joining us. And so reminder, just the last few things. Again, we will be back here, well, not here, but in Pasadena, a few miles away next year, March 9th through the 12th, returning to our home after all of this COVID fun. I appreciate you all sticking with us through the masks, through the vaccine mandates, through the tests and everything else. I know it's not fun. I hope that by next year we can skip a lot of this. No promises. It's not pandemics are not in my control. But I do know that we will be back together, all things being equal. So, with that in mind, our next speaker I don't think needs an introduction, but I first heard of him in high school. I was reading a book called Where the Wizards Stay Up Late, The History of the Internet. If you've not read it, it's a fantastic overview of just all of the early days of the internet, how things came together at various institutions to build what we now, most of us, run our careers on today. Everything from how this conference was organized to what we did through the pandemic to how I get cat litter through the mail, all organized and coordinated over at CPIP. I don't know if Dr. Cerf had that in mind when he did it, but that was interesting. So, so yeah, we're super excited. The other thing the interesting piece here is Dr. Cerf did this while he was at UCLA. And for those of you that don't know, when Scale started 20 years ago, that was done by students at UCLA and USC and UCSB and CSUN and a few other local schools when we were all we children in our freshman and sophomore years of college thinking that running conferences would be easy. One thing I can tell you is that after 20 years, the only thing I have learned is that it is not easy. But yes, so we're super excited to have Dr. Cerf, and one of the things that has been a pleasure for me over the last 20 years is just getting to meet my internet and sort of CS heroes as we bring them on stage here for keynotes and further activities. And so, without further ado, I give you Dr. Cerf, who's joining us all the way from Virginia, and appreciate him making the time as well as and for joining us. So, thank you, Dr. Cerf.
Well, thank you all very much. You know, when people clap before you said anything, my first reaction is to sit down because it won't get any better than that. Now, you all clearly understand the tactic that's been employed here. You wait until the last session of the 4 days of grueling, fantastic. I looked at the list of sessions. Holy moly, you guys have got an enormous amount of useful information, and I'm sure in the corridors in between, lots of other very useful ideas have been flying back and forth. So what you do on the last day is you get the talking dinosaur to come out. And it doesn't matter what the dinosaur says. The fact that he can still talk is amazing. So I've been given a few suggestions, though, about things to talk about. And I understand that when you get to be my age, you tell anecdotes. So we're going to go and look into the past and look at a few anecdotes. And I see more than a few gray hairs in the audience, which means I don't have any left, but my beard is doing okay. So for some of you, this will be, I hope, a kind of a fun reminiscence of things past that have taken us to where we are today. And where we are today is a big challenge. And I'll try to close my talk with some thoughts about things that we might collectively do to meet some of those challenges. And what I find most appealing, I think, about you in particular, is that you've been doing this conference now for 20 years, and there is this fellow feeling of collaborative sense of responsibility that you bring to the table that I wish everyone who writes software would bring to the table. So we're going to come to that in the last few thoughts of this talk. But let me start out by jumping into the time machine for a second. UCLA, not very far away, there were 4 nodes by the end of December 1969 in operation at these 4 locations, which were selected by the Defense Advanced Research Projects Agency for particular reasons. UCLA was selected as the first node because Len Kleinrock, who is still a professor at UCLA, ran the Network Measurement Center. And my job as a graduate student there was to write software for the Sigma 7 machine to measure the performance of the ARPANET and compare with the queuing theoretic models that Len Kleinrock's students were developing, so we could compare what the predictions were from the queuing theory models and see what actually came out from the measurements. And I can tell you that the queuing theoretic models were always beautiful and mathematical and pristine and everything else, but they didn't always predict what actually happened in a real network. And I suspect that every one of you knows exactly why that's the case. So UCLA is Network Measurement Center. Then SRI International is the second node. And that was because Doug Engelbart was at the Augmentation Research Center at SRI International. His belief and the belief of J.C.R. Licklider, who was running the information processing techniques office at DARPA, believed that computers could be a way of augmenting our capabilities. And I would say that they were right. Our capabilities today, what we do every single day, are often augmented by the kinds of software that you write and other people write to help us do things that we couldn't do on our own, not least of which, for example, is searching the entire World Wide Web. So that was the second node. And the third one was UCSB because they were doing some really interesting work on the presentation of complex functions on a screen so you could see what the computations were producing. And finally, University of Utah, because they were very much involved in computer graphics at the time. Now, you can imagine computer graphics in 1969 are not like what they are today. But one of the guys at Utah invented one of the first hidden line removal algorithms. So if you were doing 3D rendering and you wanted to show what it looked like, what the surface looked like, he had to remove the parts that couldn't be seen. So he found it was John Warnock, whom some of you will know, started a famous company called Adobe some years later. So that's 1969, many years ago. And this is a picture that was taken in 1994. It was the 25th anniversary of the ARPANET. On the left, you see John Postel, who sadly passed away in 1998. In the middle was Steve Crocker, who led the network working group that did all of the host-to-host protocols, the telnet protocols, the FTP, and eventually SMTP for email. So he was the leader of that group, and he was at UCLA, as was John Postel. All 3 of us went to the same high school, Van Nuys High, up in the San Fernando Valley. I don't know, must have been something in the air, but we became good friends at UCLA as graduate students. It took us all day to organize this shoot for Newsweek Magazine because we had to draw all those pictures of the backdrop hanging there. Then we had to go find the zucchinis and the yellow squash and the five-pound tins of coffee, and then string it all together. Now, this is Newsweek Magazine, 1994, and we thought we would put up a geek joke for those who understood it. So if you look carefully at this network, you notice that it's mouth to mouth and ear to ear, but there's no mouth to ear. This network would never work. So that was our little geek joke in 1994. But we were celebrating that anniversary of the ARPANET because without it, we would not have even bothered to do the internet. So now I'm going to skip very, very fast forward here. Past the original early designs of TCP and then later TCP/IP. This was a demonstration that I called for after I moved to Virginia in 1976 to run the internet program for the Defense Department. And I wanted very, very much to show that the TCP/IP protocols would really work across different kinds of networks over considerable distances. So we had a mobile packet radio network in the San Francisco Bay Area, driving up and down 101, radiating packets like crazy. through a gateway which had been configured to send those packets all the way across the ARPANET, which by that time extended into Europe over an internal satellite hop from Etam, West Virginia to Tanum in Sweden, and then a landline to Norway, to the Norwegian Defence Research Establishment, and another landline down to University College London, and then popped out of the ARPANET at that point into another gateway that led to the Atlantic Packet Satellite Net, which was based on Intelsat 4A hanging over the Atlantic, with multiple ground stations all vying for access to one single satellite channel. So it was like having an Ethernet channel in the sky. And then through the packet satellite network to Etam, West Virginia, down to another ground station, back into the ARPANET, all the way across the U.S. again to USC, Information Sciences Institute. So if you do the math, of course, going from the roving vehicle in San Francisco down to Marina del Rey is about 400 miles. But the packets had gone through 2 synchronous satellite hops back and forth, so it's about 100,000 miles. And I remember when we did it and it worked, I was jumping around in my office saying, it works, you know, like it couldn't possibly have worked. Listen, if it's, you know that if it works, if software works, it's a miracle. So that was a really important demonstration from my point of view as the program manager for this. Now we'll skip forward. Now we're in the early and mid-1980s. After the ARPANET and those 3 network demonstration was done, and further standardization was done, then we implemented the TCP/IP protocols on every operating system we could get our hands on. In 1982, John Postel announced that we are going to switch over from the NCP, host-to-host protocols of the ARPANET, to the TCP/IP protocols of the Internet on January 1, 1983. So this is January of 82, we make this announcement. And everybody sort of mumbles a bit, you know, everything seems to be working okay with the host-to-host protocols and Telnet and so on. So why do we have to do that? And you say, well, you know, if you don't do that, I won't fund your program next year. Oh, okay, I get that. So I had Dan Lynch, whom some of you know is the founder of Interop, was measuring how many implementations of TCP/IP he could detect on the ARPANET. And so he would report to me, you know, once every couple of weeks. And I could see that, you know, the curve was going up. And then somewhere around the summertime, it flattens out. So, you know, I'm a bureaucrat at this point. So what do? Well, you clearly create incentives. So I called the Defense Communications Agency, it's now called DISA, and I said, will you shut off the capability of the ARPANET to carry anything except TCP/IP? They could do that. It turns out there was a way to do that. And they said, turn it off for a day. So they did. Of course, the phone ringing off the hook. What's the matter with you? You blankety, blankety, blank. You know, can't get any email, you know, files nowhere. And I said, I just want you to know I can do that. So, you know, oh, okay. So the curve starts going up again. Then somewhere around late summer, you know, October or something, it flattens out again. So I called DCA, turned it off for 2 days. The phone rings off the hook. Everybody made it on January 1, 1983, except for 2 guys, and they pleaded for some kind of mercy, and we said, okay, we'll give you another month or 2. So everybody made it up. Now, how many everybody's were there? There were only 400 computers on the Internet at that point. 400 as opposed to 400 million or whatever the numbers are today. If you include the IoT devices and the mobiles, we're into the multiple billions. So it's now 1983. NSF is starting to invest in Internet technology for hooking computer science departments up to the ARPANET and then to the NSF network backbone. And they've quickly run out of gas. They essentially sent out an RFP asking for a higher speed network. Now, remember, the backbone speeds of the ARPANET were 50 kilobits a second. Okay, that was broadband in 1969. So NSFNet launches with 50 kilobits and basically runs out of gas. It switches to 1.5 megabits and lasts for a little while, and then it switches to higher speeds, and we just kept going. Eventually we end up in the multi-gigabit range. So NSF makes this big investment. They build a backbone network. They build about a dozen intermediate level networks to serve about 3,000 universities, the purpose for which is to help those universities get access to the 5 supercomputer centers that NSF and the Department of Energy are investing in. So the NSFNet comes up, and the supercomputer centers come up, and not long thereafter, NASA and the Department of Energy say, this looks like a good thing. So DOE builds the ESNet backbone, and NASA builds the NSI, or NASA Science Internet backbone. So during the mid to late 1980s, we're starting to see substantial implementation. Of course, if we go to look at the internet today, now some of you will know I'm cheating, right? Because this picture was actually generated from the BGB backbone back in 1999. But it was so colorful that I thought I would keep it because it lets me illustrate something that you know, and that is that the internet is very dispersed. There are literally tens of thousands, if not more, networks running. Each operator picks hardware and software to run, decides who to connect to and on what terms and conditions. There were no central decisions about your business model, who you connected with. The only thing we asked of everybody is please run the same protocols so that you could interoperate. We wanted to encourage, Bob Cohen and I, to encourage people to build pieces of internet, find someone to connect to, and let the system grow. So that's what it looks like today, except bigger and more colorful. It is true that there is only one centralization element, and that is trying to coordinate IP address allocation and domain name assignment so that they're unique, and that's pretty important. But ICANN doesn't dictate what is done with those things. It just tries to make sure that if you want a domain name, that it's assigned uniquely to one organization, or IP address block to an autonomous system. So this is just my little memory of milestones. I'm sure that every one of you who's been engaged in this game have your own favorite milestones. So by no means should you take this as the definitive list of important milestones. They're just the ones that I happen to remember. One very important one comes after the internet goes operational in '93, and Cisco Systems figures out that they can make money by selling routers to universities that want to get hooked up to the net and put local area networks in place. Oh, by the way, I did leave out something important. 1973, Bob Cohen comes to visit me in my office at Stanford and says, we have a problem. What do you mean we? And he says, well, the ARPANET worked, and now the Defense Department wants to see if it can use computers in command and control. But he right away realizes if you want to do that, the computers are going to be in mobile vehicles and ships at sea and airplanes. And the ARPANET was built out of dedicated telephone lines connecting everything together. Well, you can't connect the ships together that way because they get all tangled up. The tanks run over the tanks run over the wires and they break, and the airplanes never make it off the ground. So he was already starting to work on the packet radio net and the packet satellite net at the time that we met. So we started working on the TCP design. About a mile or two away, Bob Metcalf and David Boggs are busy inventing Ethernet at Xerox PARC. So that was the fourth packet switching technology that was born during this 1970s, early 1970s period. So Cisco is the first to start commercializing this stuff. The way we used to build routers was to find a computer and a graduate student. You wrap the graduate student around the computer and turn it into a router. The problem with that is we were running out of graduate students. So Cisco figures that out. Also in '84, it becomes very clear that this thing is scaling up and that we can't keep sending the host.txt file around to map the domain names into IP addresses, so we needed something that was more scalable. So Paul Macapetris and John Postel invent DNS, and it evolves over time. But it certainly has scaled dramatically. It's a pretty brilliant piece of work. So around 1988, by this time, Dan Lynch is doing Interop, and it's up in the San Francisco Bay Area. And I walk in 1988. He started in '86, then it was an exhibit. Oh, and the deal was you can't exhibit unless you show that you can interwork with everybody else. So they'd bring out the show net, this big fat yellow coaxial cable. You all had to plug into it and then show that you could talk to everybody else in the show. So Eric Benemu, who was then the CEO of 3Com, the company that Bob Metcalf started to sell Ethernet, and I walked into the show, and the first thing we encountered is a 2-story Cisco thing, display. And so I turned to Eric, and I said, Eric, how much do those displays cost? And he says, about $250,000. This is 1988, and I'm sort of sitting here saying, oh, that's a lot of money. And he said, and that doesn't count the people who had to stay there and man the booth for a week. And so I'm just standing there, my jaw is dropping, thinking somebody thinks they can make money out of the internet. That's amazing. At this point, I'm starting to wonder, because how are we going to let the rest of the general population get access to this thing? Because up until that time, all of the networks were funded by the government agencies, NASA, DISA, DISA was also NASA, DISA, NSF, DOE, and DARPA. So there was an appropriate use policy that said no commercial traffic will flow on a government-sponsored backbone. And you could imagine a rationale for that. They didn't want government resources to support commercial activity. But it became increasingly clear that even the people who were doing research under government grant actually needed access to commercial services that could be reached on the internet if it were permitted. So at this point, I'm working with Bob Cohen and his company, the Corporation for National Research Initiatives. And I had taken a little break from the internet from roughly 82 to 86 to build something called MCI Mail, which is a commercial email service. So in 88, I'm sitting here thinking, okay, so what could I say to the federal government that would let me break the appropriate use policy without really appearing to want to do that? So I called the Federal Networking Council, which at the time was mostly NASA, DARPA, NSF, and NASA, DARPA, NSF, and DOE. Their program managers were the people who managed the internet policy. So I called them and I said, would it be okay if I tried to connect the MCI mail system to the internet and see if we could get the email stuff to interwork? And to my surprise, they said, well, okay, for a year. This is just an experiment. So by summer or so, 1989, we announced we have a gateway between the MCI mail system and the internet. And as soon as we make that announcement, all of the other commercial email service providers, which are islands into themselves, right? You can't talk to anybody unless you all have an account. So things like Telemail and OnTime, CompuServe, yes, all of those, say, wait a minute, these MCI guys can't have this special treatment. We want on too. And so the government says, okay. So they all get hooked up, and two things happen. First thing that happens is they all discover that all of their customers who used to be trapped in a walled garden can talk to all the other customers of their competitors plus everybody on the internet because they were all compatible through the internet mail protocols. And that was a little surprise. And then later, mail becomes almost free. So much for that business model. But the second thing that happens about the same time, maybe a little later in the year, is 3 commercial internet services pop up because we've just broken the AUP limitation. So UUNet in Virginia and PSINet in Virginia and SurfNet in San Diego all get started in 1989. Okay, yeah, this is anecdote number, 17. SurfNet used to be spelled SURFNet. And of course you'd do that. You're in San Diego. What else would you do? So they had the whole campaign all laid out, T-shirts, surf the internet and all this stuff. And then a couple of weeks before they actually launched, somebody discovers that there's an organization in the Netherlands called SurfNet, which is, it's a Dutch acronym, and they are building a network to connect the universities in the Netherlands. So they can't call themselves SURFNet. So Susan Estrada was the executive director at the time. And So somebody says, well, why don't we change our name to the California Educational Research Foundation Network? Because, you know, it sounds the same. And then somebody says, maybe we should call it MIN. So they call me up, and they say, can we call it SurfNet? And my first reaction was, you know, if they screw this up, am I going to be embarrassed? And I thought about it this morning. Wait a minute now. People name their kids after other people, and if the kids don't come out right, they don't blame the people they named them after. So I said, sure. So I flew out to California in 1989, and Susan and I had a plastic bottle full of glitter, and we smashed it on a Cisco router, and we launched the SurfNet. So by that time, we're starting to see real commercial services pop up. Rick Adams was the founder of UUNet, and so we're talking 1989. So 1997, he sold the company for $2 billion to Metropolitan Fiber Systems, which on the same day was acquired by WorldCom for $14 billion. So he made out okay. That worked. That was good. So just, you know, picking a few more of these things. The big deal after commercialization, of course, is when Tim Berners-Lee announces the World Wide Web, which is late December, as I recall. And I don't think too many people actually noticed. He was doing it on a Next machine, which is very cool, at CERN. But not too many people noticed, except for these two guys, Mark Andreessen and Eric Bina, at the National Center for Supercomputer Applications in Urbana-Champaign. And they look at the text-based interface and they say, boy, it would be really cool if we could make a more graphical interface, wouldn't it? So they do Mosaic. It comes out around 1993. And everybody notices, because suddenly the internet looks like a magazine with formatted text and imagery and eventually streaming audio and video. So that was a big deal. And Jim Clark, the founder of Silicon Graphics, takes one look at the Mosaic browser and he says, this is a big deal. You know, remember, he started Silicon Graphics, which turned out to be based on another chip that ARPA funded called the Geometry Engine. So he flies out and he takes Mark Andreessen and Eric Bina and maybe a few other people back to the West Coast to start Netscape Communications in 1994. And by that time, I had left Bob Kahn's organization to rejoin MCI to put them in the internet business. And the first thing they wanted to do is build the MCI Mall. Okay, so I fly out to Netscape and buy $7 million worth of licenses for Netscape's browser and server. And first thing I asked them to do is to figure out how to avoid having my servers filled with partial transactions that won't ever get cleared away and I won't know when to get rid of them. So please store the partial transactions on the user's computer. And so they went away and came back with cookies. So if you're wondering where cookies come from, you can blame Mark. No, don't blame me. So that, you know, of course, they go public in 1995. The stock goes through the roof and the dot boom is on. The venture capitalists in San Francisco are throwing money at anything that looks like it might have something to do with the internet. And this goes on for a while. In 1998, in the midst of the dot boom, Google gets started by Sergey Brin and Larry Page. Yahoo gets started a little bit before that to surf the internet. The interesting thing about the arrival of the World Wide Web is that it triggered an avalanche of content that flowed into the net. It was so interesting. People were not looking for money for the content. They just wanted to know it was useful for somebody else, kind of like what you do. So this avalanche pours in. Pretty soon nobody can find anything because there's so much of it. So they need search engines. Some of you will remember Alta Vista, which came out of the digital research labs on the West Coast. And then Yahoo comes along, which was kind of more manual, I think, than some of the others were. And then Google, of course, with its clever strategy called PageRank, which was very successful. It didn't have a business model to start with, by the way. It was no business model. But not very long after it got started and after they brought Eric Schmidt in as the CEO, sort of adult supervision, then this three-way business model evolved, which was quite successful. ICANN gets started in 1998, and the original idea was that John Postel would be the chief technology officer for ICANN, and it would manage the domain name system and IP address allocations through the regional internet registries. As I say, John passed away in September of 98, but ICANN was really needed, so they proceeded. Now, one thing I have not done is to tell you about the 1978 to 1993 protocol wars between the Open Systems Interconnection model and TCP/IP, to say nothing of X25 and X75 and X29 and so on. That would take too long, so I won't do that. But a lot of people imagine that this is just smooth sailing and it was just step by step and everything was all planned out, and nope, it was Sturm und Drang for many, many years, and it's still Sturm und Drang today. So just pushing a little further into time here, a few other things. The dot bust happens in 2000s around April. Big lesson there. A lot of the startup CEOs apparently didn't understand the difference between revenue and capital. And in Economics 101 says you have a finite amount of capital to get your revenue engine going. And if you don't get the revenue engine going, you will run out of capital, and then what? So lots of dead bodies, of startups in 2000. But the internet kept going. The demand for that capability was still very strong. So YouTube gets started in 2005. Amazon Web Services comes up in 2006. The iPhone shows up. Now, I want to emphasize the iPhone for a moment because all of you, I'm sure, know what a transforming event that was. But now, this is anecdote number 17 or 18, I guess. Some of you may know that the mobile phone was invented by a guy named Marty Cooper, who was working for Motorola at the time. What you might not know is that he started working on it in 1973, which is when Bob and I started working on the internet, and Metcalf starts working on it. Something going on in 73. I don't know what it was, whatever we were drinking. So anyway, this thing gets started in the same year, 73, and it gets turned on in 1983, the same year that the internet gets turned on. So Danny Cohen, another name you might know, is very much influential in the internet's splitting of TCP and IP because of real-time operation. He was all involved in packet speech, among other things. So Danny calls me up in early 1983 and says, "Come have lunch, I have something to show you." So I show up, and he's got this thing sitting on the table. It's about this tall. It's got a whip antenna on it, and it weighs about 2.5 pounds. And what's that? He says, it's a phone. I said, well, where are the wires? There aren't any. Well, how does it work? So we talked about it for a while. And he said, I don't know the answer to that. Why don't you call the guy that invented it? So I called Marty Cooper on a Motorola brick, which is what we called it then. And the first question I asked Marty was, how long does the battery last? And he says, about 20 minutes, but you can't hold the phone up longer than that anyway. So Marty, bless his heart, presses on. He's still around. He's still around. He's in his 90s now. He's just written a book about the whole story of the invention of the mobile phone. But the iPhone is really triggering, as every one of you knows. When Jobs figured out something that none of us realized that we wanted, which is a device that had a camera, it had access to the internet, it had access to the telephone system, it had a touch-sensitive display. I mean, it's got all of these amazing features, all of which existed as a technology never put together in such an interesting way. That transforms everything because suddenly the internet is more accessible. Anywhere you get a mobile signal, you get to the internet. And of course, the mobile phone gets more useful because it gets access to all the applications that are running on the internet. So the two are mutually reinforcing. It's really powerful, man. So 2007 is a big deal. In the world that we now inhabit, in 2008, 2009, several developments came out of the academic world, Ethane, OpenFlow, and Knox. This is basically software-defined networking, which really has transformed the face of building networks today. And in fact, in 2010, Nick McKeown and his colleagues started a company called Nicira to build software-defined networks. And lots more. I'm not going to try to repeat the last 10 years of development. And you've lived those last 10 years anyway, so you know them as well as I do. But they are pretty astonishing, and you guys are a part of that. So somebody asked me to look back and say, what would you do differently? And so I decided I'd put a little list together. The first one is obvious, right? I would have done IPv6 first instead of IPv4. But because it's been damn hard to cause an incompatible introduction of a new protocol at that low level in the architecture. In our own defense, though, we actually did a calculation when we were doing the original design of TCP to see how much address space we ought to have. Now remember, it was an experiment and we didn't know if it was going to work. So we said, okay, it has to work everywhere in the world because it's going to be supporting the Defense Department command and control system. So we said, okay, so how many countries are there? How many networks per country? And we thought, well, how about 2, so there'd be some competition. Then we said, how many countries are there? And there wasn't any Google at the time to ask, so we guessed at 128 because that's the power of 2. And you know, we did the math, 256, that's 8 bits. Okay, so we know how many networks we got to deal with, 256 networks. And then how many computers per network? How about 16 million, which is, at the time, they were millions of dollars. And they didn't move anywhere. They were in air-conditioned rooms, and they were hooked together with wires. But we thought, what the heck? And besides, it rounds it out to 32 bits, which is cool. So, and we thought, you know, that's 4.3 billion terminations if you could allocate them densely. Of course, you never would, but if you could. And that was more than there were people in the world at the time. So we thought, that ought to be enough for an experiment. Now, I want you to imagine, you know, that you're a young Vince Cerf in 1973, and you go and your future self goes back and whispers in your ear and says 128 bits of address space, and your younger self says, WTF? That's 3.4 times 10 to the 38th addresses. And you say, yeah, I don't think I can sell that. It doesn't pass the red face test. Your network has never even been demonstrated, and you're telling me you need 10 to the 38th addresses? So I don't know if I would have gotten away with that. Now, there is a huge mistake that I made for mobility support. This one, it's amazing how you can fool yourself into thinking you solved the problem when you actually haven't. I remember splitting TCP and IP, and then we had to figure out how the TCP identifiers would work on an end-to-end basis. So we created a pseudo header sucking the IP addresses up out of the IP layer into the TCP layer and used that for socket identification. And since I had an operating mobile radio network at the time, I thought we had dealt with mobility. Except for one thing. I didn't think about the possibility that your mobile would move from one network to a different network that had a different IP address space. And at the time, I was thinking, okay, I know. I can put another address space at the TCP layer so that it's okay to switch IP out from under the TCP. And those of you who know about QUIC know that the QUIC protocols establish a cryptographic shared variable at the upper layer, at the QUIC layer. So if an IP address changes, not both, but if one of them changes, you can reconstruct the network. If they both change, of course, they can't figure out who to talk to, so that doesn't work. Anyway, I thought that the mobile problem had been solved. Clearly, it has not been solved. So that was a big mistake, and I regret that. But at the time, I was patting myself on the back for saving bits in the header. So, you know, be careful what you congratulate yourself for. The other thing that has occurred to me is that radio has wonderful features, one of which is broadcast. You can transmit in all directions if you want to. And we don't use that in any of our protocols in a serious way. We kind of could do it, especially with synchronous satellites. You can imagine a protocol where a bunch of stuff gets sent to lots and lots of receivers, and the guys that didn't get it could raise their hand and say, please send me another copy. But we never really built any protocols to take advantage of that. Maybe that's something we should think about. Another thing that we could have done is put crypto into the system sooner than we did. And a lot of people come and say, you know, blankety blank, you idiot, why didn't you put more crypto in at the beginning? beginning, we wouldn't be in such a mess that we are today. I don't actually think that's true. But at the time, in 1976, when Whit Diffie and Marty Hellman published their first paper on new directions in cryptography, it was stunning. And I'm sure the guys in the UK were especially stunned because they'd invented this idea in 1974. But they didn't tell anybody because they didn't want anybody to know about how clever this was. So anyway, the paper gets published, and the next year or so, 78 or so, the RSA algorithm to implement this idea gets invented. Now you could say, why the hell didn't you just immediately implement the public key crypto? And my reaction, remember, is 1977. I'm trying to get the damn thing demonstrated and implemented on as many operating systems as possible. And I look at the RSA idea and I said, this is retrofittable. I can put this in anytime. And so I wanted to get the system up and running and demonstrate it first. So we did that. We were actually working using DES, which is a conventional symmetric key, to build a cryptographically secure system. And we were demonstrating that with a program called Black Crypto Red. I'm sure some of you know the red side of the net is the sensitive side, the black side is post-crypto. And we stuck DES in the middle. But key distribution is not nearly as nice with the symmetric keying system as it is with the public key system. But anyway, so we were clearly working on the crypto support. And of course, the NSA was busily doing some of its development work as well. But I remember thinking at the time, okay, if I were serious about insisting on cryptographic implementations, who are the users of this thing? It's graduate students, and I don't mean any offense because I was a graduate student once too, but I can't imagine graduate students being really good about key management and all the other things that you have to do. And so I kind of was comfortable not doing that and not insisting on it too early in the game. And of course, multi-factor authentication would also have been a good thing to have thought about if we had any technology to support it, because even then everybody knew that passwords were a terrible idea. So here we are. We really want to add more security to the system. And so from my point of view, we really need work on BGP. I'm sure all of you know how easy it is to either be hijacked or just make a dumb mistake configuring something wrong. Almost all the really bad stuff that happens most of the time is somebody just making a mistake. Sometimes it's not. Somebody did it on purpose. RPKI is another thing that I'd like to see more implementation. Ditto DNSSEC and DANE. So those are all things that we should be working on. I also think that more strong authentication in the system, all the way down to identifying a hunk of hardware and being able to authenticate that it is what you think it is, would be very helpful. The Internet of Things really, really needs something to keep your simple IoT devices from being hijacked. Like the, what is it, 500,000 webcams that were hijacked to do the DDoS attack against Dyn, which had cascade effects because Dyn was doing everybody's domain name resolution for a lot of very important companies, and they all disappeared off the net because Dyn fell over. Which, by the way, hang on to that thought for just a second, because if you're like me, you may be needing a change of underwear, because if you think about how dependent we are on certain key parts of the architecture, and you can see when they don't work, there are cascade failures. If your mobile doesn't work, battery's dead, can't get a signal, some other problem, then you can't do two-factor authentication maybe, or you just can't get into your email, so the business deal you were about to close doesn't happen. I mean, more than once, even just over this weekend, I had to go through a whole series of login and authentication steps, some of which involved mobile. I now got two devices that I have to make sure work. And everybody in this room knows that the probability of success is multiplicative. So 90% successful times 90% successful is 81% successful if you rely on both things working. And if there's a third thing, it just gets worse. So we are steering right now into a very fragile future, in my opinion. And I hope those of you who are thinking about software development architectures and things like This isn't just a question of more security. This is more resilience, more alternatives. Like every screen ought to be useful for this authentications if you need it, things like that. Now, some people have criticized the basic assumption that we made that every device on the internet should be able to talk to every other device. And the reason that we chose that as our principle was that we didn't know which devices were going to need to talk to which devices at the time. And so we had no rationale for inhibiting communications. Now today we look back and realize that since everything can talk to everything, then the bad guys can talk to everything, and they do, and they cause trouble. So it could very well be that we should reconsider how to hide parties from exposure. And there are some suggestions and the sort of clean sheet designs that are coming to that. I've already mentioned about the dependencies. So, and I'm also very conscious of the fact that I can't even read my own watch. Now, those of you who have good eyes will know that this is a Ronald McDonald watch. And I only have 10 minutes left. I got this for teaching a class in networking at Hamburg University, just outside of Illinois. I am not kidding. There is a university. They teach people how to run McDonald's, and they were about to network them all together so they could keep track of the sales and the use of resources and everything else. And so they gave me a Ronald McDonald watch to commemorate the thing. So anyway, let me just riff for a second on open source and open standards, because that's what you do. And I tell you, what you do is really important. I still consider it to be one of the central engines of the evolution of the internet. Your willingness to share your code and your thoughts and your ideas and everything else. It's wonderful. Think about what happened with the World Wide Web. There was no class in being a webmaster. But what you got to do with the browser was say show source. So you could see, how did they make this really cool web page? Because you could see the HTML. And so lots and lots of people learn how to be webmasters from each other. And that's what you do. You learn from each other, which is great. It accelerates the pace of development. It also, open source also gives you an opportunity to find bugs. Now there's a little problem with this. Sometimes open source leads people to think it's open source, everybody's already found the bugs because it's open source, therefore you don't need to look. Yes, you can stop laughing now. So I do worry about that, and I have pushed very hard wherever I can to argue we need to support people like you more so that you can help us make more resilient and more stable and safe software. It's really tough because the curation of this software is really important. Some of the bugs, as some of you know, lie around for 20 years and they just don't get noticed until they surface at exactly the wrong time. There's lots of supply chain risk factors that are involved because the open source software can be anywhere in the stack. And a bug that gets in deliberately or malware that gets in deliberately can be really troublesome. So there's a real challenge for us as a community to support open source software in a sustainable way. So I just want you to know I'm a big fan of trying to find ways to do that. We need this stuff, the standards and the open source, for interoperability. Some people say standards inhibit competition, but I don't agree with that. I think that having commonality and interoperability allows for competition on top of the standardized platform. And of course, we all need to remember that we want to adapt our software to whatever new platforms have come along, Kubernetes and containers being a very good example, virtual machines and so on. This is a slide which I don't have time to talk about, but I want to just pause and ask you to look at it for a second, because these are all problem spots. They are not a full list. They're just some of the challenges that lie ahead. Some of them are really tricky because they involve international agreements of some kind, whether it's treaties or norms or something else. Think for a minute about the world that we wish we lived in, one where accountability is enforceable and that agency is given to people and companies who are using the internet. Accountability and agency. And in order to make that work, you give up some anonymity, because if you can't hold people, you can't hold anonymous people accountable. And so if they're deliberately doing harmful things, you have to have a way of tracking them down. It's a little bit like license plates, and it's not a perfect analogy, but you know, license plates are gobbledygook, except mine, which says "Surf's Up." So most of them are just random stuff. But the police department is permitted to penetrate the veil and find out who owns the car. It may not be the person who was driving the car, but if they can penetrate that veil because it's their